In this video, we're going to be using implicit differentiation first to find the slope of the tangent line at -1, -1. Once we have the slope, we'll use it to find the equation. Let's begin. Okay, so with implicit differentiation, what's the first step? The first step would be to take d dx of the entire equation. D dx of x squared plus xy plus y squared is equal to d dx of 3. Okay, now what is d dx of x squared? What is the derivative of x squared with respect to x? It's going to be 2x. What is d dx of xy? So the derivative of x times y with respect to x. What rule should we use here? We should use product rule because it's x times y. Okay, so I'm gonna get another sheet of paper. Whatever I write on here, you don't have to copy when showing your work. I'm just gonna write some stuff down here to elaborate on certain things. But, okay, so we want to find d dx of x times y. Okay, so how do we use product rule here? Well, I can let this be one function. I'm going to let this be f of x. And I'm going to let this be another function. Okay, so this is the same thing as finding d dx of f of x times g of x. And what rule can we use here? To find d dx of f of x times g of x, we can use product rule. All right, so if f of x is equal to x, then f prime of x is how much? 1. Okay, and then times, what goes here? Y, and then plus, what is this equal to? X, and g prime of x. Okay, so if g of x is equal to y, g prime of x would be equal to dy dx. So dy dx. All right, so let's go back. We're going to try to redo our steps from memory. So what is d dx of xy again? What rule did we use? Product rule. Okay. So it's going to be plus. What is d dx of x again? So d dx of this is 1, and then it's going to be 1 times this, or I'll just put a parenthesis here, and then it's going to be plus this times d dx of this. Okay. Now we still have to add d dx of y squared. So what's that going to be equal to? Okay, so we want to find d dx of y squared. Okay. Well, if I let f of x be equal to x squared and g of x be equal to y, then what does this turn into? So this is going to turn into d dx of g of x squared, okay, and okay, so g of x squared, what happens if I turn all the x's here into g of x's? Then I'm going to get f of g of x is equal to g of x squared. Okay, so this turns into d dx of f of g of x. What rule should we use here? We could use chain rule. So f prime of g of x times g prime of x. Okay, so derivative of outer times derivative of inner. Okay, so what's g of x equal to again? Okay, and then g prime of x is, okay, so if g of x is equal to y, what's g prime of x? dy dx. What's f prime of y? So f of x is equal to x squared. F of y is equal to y squared. So f prime of y would be 2y. Yeah, I'll just write it here. So f of y is equal to y squared, and then f prime of y is equal to 2y. Okay, I'm going to copy this. All right. So plus, so 2y times dy dx. Okay, and that's equal to, what's d dx of 3? 0. Okay. Now, what's the second step with implicit differentiation? The second step would be to get dy dx by itself. Okay, so how do we do that? Well, let's group all the terms that have dy dx in them together. So, okay, so it's going to be dy dx. Okay, so first off, this reads as 2x plus y plus x times dy dx plus 2y times dy dx. And I factor out the dy dx. It's going to be dy dx times x plus 2y. And then we've got, it's going to be plus 2x plus y on this side. Actually, let's get this sheet out again. Another sheet. Yeah. Okay, so this is the same thing as 2x plus y plus x times dy dx plus 2y times dy dx equals 0. And then I factor this out. Okay, and our whole goal is to get this by itself, right? So before we get this by itself, we need to get this by itself. So what should we do to both sides of this equation? Subtract this. So subtract 2x and then subtract y. Okay, what's next? Divide both sides of the equation by this. Okay. All right, so we need to write this down over here. I'm just gonna jump straight to this step. When writing out the steps that we're gonna be turning in. Yeah, I think the grader will know. Okay, they grouped the terms that have dy dx in them together, and they moved this and this to the other side of the equation. Okay, and then what was the next step again? Dy dx is equal to negative 2x minus y over x plus 2y. Okay, so that's dy dx. That is the slope of the tangent line. But to find it at -1, we need to plug in -1 for x and -1 for y. Okay, so let's go ahead and plug it in. Actually, I'll give you a second to pause the video and plug it in. Okay, what did you get? So -2 times -1 minus -1 over -1 plus 2 times -1. Okay, so that's 2 plus 1 over -1 minus 2. So 3 divided by -3 is -1. Okay, that's the slope. And I'm going to write equation of tangent line at -1, -1. Okay, so the equation for a line, it's of the form y equals mx plus b. Now, what does m mean? M means the slope. So we're going to change m to -1. What else are we going to be changing in this equation? We're also going to be changing x and y. We're going to be plugging in -1, -1. So we're going to be changing x and y to -1, -1. Okay, so -1 equals -1 times -1 plus b. So b is how much? Okay, so -1 equals 1 plus b. That means b is equal to -2. So the final equation for the line is going to be what? So let's go back to this and plug in everything. Plug in m and b. So y is equal to -1 times x, so -x, and then plus -2, so -2. This is your answer. And if you want to double check this, I encourage y'all to go on Desmos or Graphing Calculator and graph this, and then double check and see if this is tangent to this at -1, -1.